10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX, Godspeed, Bob and Doug.
America has launched. So rises a new era of American spaceflight, and with it the ambitions of a new generation continuing the dream. 20 seconds into flight, stage 1 propulsion is nominal.
T plus 30 seconds into this historic mission. Flying crew on board Dragon and Falcon 9, and look at them go!
Falcon power telemetry nominal.
¿Qué tal? ¿Cómo les va? Muy buenas tardes. Bienvenidos a otro episodio de Ecos de un Mundo Estrellado. Bueno, vamos a empezar el programa recordando esa fiesta que fue el retorno de los astronautas de la Crew Dragon, la Dragon tripulada de SpaceX, cuando se abrieron esos paracaídas bellísimos, veíamos cómo poco a poco y lentamente la cápsula que traía a los dos astronautas, Douglas Hurley y Bob Behnken, caían y finalmente amerizaban, ¿no? Vieron ustedes que cambiamos la presentación del programa y también el cierre. De alguna manera vamos a estar compartiendo ahora este momento porque sin duda que fue un punto de inflexión, ¿no? Como un antes y un después, porque por primera vez una empresa privada está transportando seres humanos y retornándolos a la Tierra. Y hacía mucho tiempo, casi 50 años de la misión Apolo 17, que no veíamos un amerizaje. La verdad que fue muy lindo, muy emocionante. Nosotros hicimos una transmisión en directo con nuestro canal Ecos de un Mundo Estrellado en YouTube, que dicho sea de paso pueden suscribirse aquellos interesados. Fue seguido por mucha gente. Los astronautas la verdad regresaron bien. Después contaron en una conferencia de prensa cómo fueron los ruidos, cuál fue el golpe que se sintieron cuando amerizaron. Nada que gente que está muy entrenada, por supuesto, que está sometida a un intenso entrenamiento en la NASA no pueda resistir. Ni siquiera aparentemente se descompusieron y tuvieron náuseas, todo realmente perfecto, tal cual había sido previsto. Y bueno, y ahora se vienen otros lanzamientos. Ya SpaceX y la NASA están pensando en septiembre para la primera misión oficial de la Crew Dragon. Esta fue de testeo, que se va a llamar así Crew Dragon 1, donde ya hay 4 astronautas que van a participar en la misma. Así que bueno, la carrera espacial sigue y la verdad yo diría más estimulante que nunca, con mucha actividad y con mucha positividad en el ambiente. También quiero contarles que participé en estos días de un nuevo congreso de la IPS. La IPS es la Sociedad Internacional de Planetarios, si lo traducimos al español, de la cual soy miembro, porque ustedes saben que yo tengo un planetario portátil con el que recorro y visito las escuelas. Muy lindo encuentro realmente con la gente, algunos de ellos que hacía varios años que no veía y que fue virtual, por supuesto. Ustedes ven acá algunas imágenes que tomamos por Zoom, como son todas las cosas ahora. Pero fue también una oportunidad justamente para que aquellas personas a los cuales nos cuesta acceder, porque los costos económicos para viajar son importantes, realmente pudimos hablar de esta herramienta mágica, única para inspirar y para enseñar, que es el planetario. Y ojalá, otra vez lo vuelvo a decir, la ciudad de Paraná pueda terminar la obra del planetario, que como ustedes saben está a mitad de camino en el nuevo parque. Vamos a recordar nuestros auspiciantes y luego seguimos aquí en el programa.
En el marco de su plan energético a 10 años, ENERSA desarrolla obras de infraestructura en toda la provincia para acompañar el desarrollo productivo, permitir la radicación de nuevas inversiones y garantizar el bienestar de las familias en sus hogares. Más de 1.100 millones de pesos destinados a obras eléctricas para beneficio de todos los entrerrianos. Plan energético a 10 años. ENERSA, Gobierno de Entre Ríos.
Honorable Consejo Deliberante de Paraná, un espacio de pluralidad y voz ciudadana. Entérate de lo que pasa en tu ciudad ingresando a www.hcdparaná.gov.ar y seguinos por las redes sociales, Facebook y Twitter.
En el año 1984 se encontró en la Antártida, en unas colinas que se llaman Allen Hill, se encontró una piedra, una roca, que luego analizada se supo que su origen era marciano. ¿Sí? Hay piedras que se han encontrado en la Tierra, meteoritos, como tenemos en el Observatorio Astronómico Oro Verde, cuyo origen se sabe, su procedencia es marciana, porque cuando se analiza la composición química coincide realmente con una gran precisión con la que hemos obtenido de los rovers y de las naves que han bajado en Marte. Así que estamos seguros de eso. ¿Qué pasó? Alguna roca impactó con Marte y luego eyectó piedras y algunas de ellas se encontraron en la Tierra hace, quién sabe, millones de años atrás o decenas de miles de años atrás. La cuestión es que en el año 1996 la NASA se encuentra con algo sorprendente. Se encuentra con una serie de deformaciones, vamos a decir así, que parecen indicar la presencia de vida fósil en la piedra. Si ustedes ven esta imagen, ¿no parece eso una bacteria? Bueno, gránulos extraños, magnetita, lo que parecen ser microbios, toda una serie de estructuras y formaciones muy bien organizadas que llevaron incluso al mismo presidente de Estados Unidos, Bill Clinton, en esa oportunidad, a decir que la humanidad por fin había encontrado que había fuertes evidencias de que habíamos encontrado vida extraterrestre. Eso abrió un gran debate y después empezaron a venir trabajos que empezaron a poner en duda y a refutar este origen biológico, diciendo no, hay explicaciones que pueden ser no biológicas, explicaciones geológicas, y bueno, inició un arduo debate muy controvertido que sigue aún hoy. Y yo hace, no sé, unos 15, 20 días me encontré con un artículo de un futuro libro de una escritora científica llamada La búsqueda de vida en Marte, una historia de detectives fascinantes que tiene que ver con la historia de este meteorito. Ella se llama Elizabeth Howell y vive en Canadá, vive en Ottawa, es doctora en filosofía. Y escribió un libro sobre el tema y la verdad que tuve muchas ganas de entrevistarla. Y la verdad que fue muy gentil, gracias a mi amigo Pablo de León, que está en Dakota del Norte, que la conocía y así pude acceder a ella para poder conversar. Es una nota que hicimos en inglés, por supuesto que le puse subtítulos en español, espero que la disfruten. Aquí va. We are talking with Elizabeth Howell. She is science journalist, communications consultant, doctor of philosophy, and she wrote the book The Search of Life on Mars, where she tells the fascinating story about a rock that came from Mars with evidences of life. Why you are doctor in philosophy, but you are science journalist too.
That's right.
And you choose space journalism. Why?
When I was a kid, I saw the movie Apollo 13, and I wanted to be an astronaut.
Okay.
And as I got older, I decided that there are other ways of participating in space that don't require me to go into space. Although, if you know of somebody who wants to bring me there, you tell me. I will go tomorrow. However, I, over the years, wrote stories about space. I've met astronauts. I've attended rocket launches. I've been to the Jet Propulsion Laboratory, NASA's place where they built the Mars rover. So there are many, many ways that you can be in space without needing to get on a rocket, right? So that's what I found out, and that's why I do space journalism. There's always something new to discover, don't you think?
Oh, yes, I agree.
Yes.
So, Elizabeth, in 1995, two NASA scientists scanning a rock that came from space, maybe from Mars, with an electronic microscope, found evidences of what looks like fossil life, microbes, bacteria, and after a year, an announcement was made that involved the President of the United States, Bill Clinton. You remember?
Yes, I do. I was small at the time, but I remember. Yes.
Tell us more about this story and why you choose to write this book in particular.
Well, what happened was they made an announcement that they thought they found life inside of this rock. And immediately the science community had a big argument because some people said those little traces of fossils were not actually fossils at all. And to be honest, the debate still goes on today because we have better instruments. We have a better understanding of what used to be on Mars in the ancient past. And so we keep looking at this rock and we keep trying to decide what it is and what it isn't. So that's where the debate comes from, because if you look at even old rocks on Earth, look at the fossils, if you go back far enough in time, it's hard to tell because of all the activity on Earth in terms of the geology, the plate tectonics, what has happened to that rock because it's been squashed, it's been maybe put in a volcano and out again, right? So there's a lot of different types of history that affect what a rock looks like. And sometimes those changes can look a little bit like life, right? So you need to have better investigations. In the case of this meteorite, too, it went through Earth's atmosphere. So how did Earth's atmosphere affect the composition of the rock, right? All of these questions. So the reason that we wrote this book was actually in part because of this story. Over time, we've been learning more and more about Mars by looking at rocks, such as this one. Also, we have sent all these missions to the red planet to look at water, to look at its atmosphere, to look for signs of life, potentially. And the idea is, just like a detective story, you get clues, right? Time after time after time. And then hopefully you get enough clues to build a case at the end. So that's why we wrote the book.
Why we are so sure that this rock came from Mars?
Well, it has to do with what the rock is made of. And so Mars has a very different geologic history than Earth, even though the two of them are rocky planets. For example, Mars happens to have fewer plate tectonics. It's stopped early in its history. And also just the surface of Mars is made up in a different way than the surface on Earth. The surface on Mars, for example, has a lot of materials that can be oxidized, meaning that they get a little bit rusty, and that's why you see the red coat on it. So basically what people did was they compared the rock that we had here on Earth with rocks that we found on Mars and found that it was very similar in terms of the composition.
Yes, and the rocks have part of the atmosphere of Mars inside.
They do as well.
Keep.
Yep. So the
That's
atmosphere of
interesting.
Mars is mostly made up of carbon dioxide, whereas on Earth it's mostly made up of nitrogen and oxygen, right? And so there's a little bit of the atmosphere embedded in the rock, which also told us that potentially, well, actually it is from Mars. So there are a lot of reasons why this rock is not from here.
Okay, so they spent almost a year before they made the announcement. You know what Carl Sagan said: extraordinary claims require extraordinary evidences. You think that maybe they rush to make it public? Maybe they should have been more prudent, more cautious?
I think the trouble is the science community doesn't exist in a vacuum, so to speak. Everybody talks, even if you're trying to keep things quiet. And so after a time, you do need to bring your results publicly, if only to have a discussion. Maybe you can bring them out and just say, these are interesting results, and what does the rest of the community think? I think what the problem was perhaps it was not presented as a question. It was more presented as this is the truth. And then what happens is in the public, if you say this is the truth, there are people without scientific training that don't understand that sometimes science is a process. It takes time. So that's why you were seeing announcements from example, Bill Clinton, the president at the time in the United States, about this, because he and his administration perhaps did not have all the science training they needed to understand what was going on. So I don't think the mistake so much was presenting the results, just maybe how they presented the results was the problem.
Okay, so what they found? They found carbonates, organic molecules.
Yes.
This is not pretty standard. What about terrestrial contamination? They rule out? They discard terrestrial contamination?
There might have been some contamination, and that's the controversy, right? Because some teams said there were more contamination than other teams. So that's why there was such a dispute. It's hard to tell how much contamination there is.
They found also magnetite, a magnetic mineral made of iron, oxygen.
Exactly.
They knew was normally produced by bacteria, at least in this way.
They said it was produced by bacteria, but other scientists said there might be other processes that produce these bacteria. Sorry, not produce the bacteria, but produce these patterns. That's the question when you're looking at very, very early rocks, whether it was made by life or whether it was not made by life.
And these amazing colors of the globules, orange. This is, you said that this is an experience that few have experienced firsthand, you know. We are talking about an orange color only in this meteorite or carbonate globules in general?
I'm not a geologist, so I don't want to
Uh-huh.
be, precluding what others have found, but it is unusual. I will say that much. But I'm sure that if we had enough study, we would find out other rocks. Perhaps other rocks have already been found.
Okay, so the controversy goes on.
Yep,
Uh,
it goes on.
if you need to make a choice in based from what you read and investigate, you decant for a geological or biological explanation right now.
Again, I'm not a geologist and I'm not a biologist. I can't really say. But what I will say is maybe it would be good to have a second sample that looks very similar to this sample. Okay, you want to have not just one, but two. So go and find me another rock that looks like this one, and then maybe find me a few scientists I can talk to, and I can give you the answer then.
Okay, but they
Yeah.
say they found another rocks, maybe 15 rocks from Mars.
Yes,
They
so
didn't
other
find
research
they didn't
now,
find anything in these rocks.
not the same. No, so they're
Ah,
still doing a lot of investigations of these rocks. The problem is you don't just look at a rock for a day and it's done, right? It takes years sometimes to go through it. But no, nobody has found exactly the same structures, as far as I know, than this particular rock you're talking about, the Allen Hills one.
they sent samples, Elizabeth, to other laboratories before they made the announcement to compare
I don't
to other scientists.
I would assume so, but I don't know offhand. I would need to go and take a look at the research. It's a lot of detail that's hard for me to memorize right on the air. So I would just say that if you're not sure, then just go and dig into the research yourself.
Because this is very important in science to
It's
cross the
very important in
results,
science.
uh,
Exactly.
reproducibility. This is very important.
You want reproducibility and you want other scientists to take a look at the work. And I would assume that the team probably had at least some informal discussions. Usually, what happens in science, though, is that one team might make a paper about a particular finding, then other teams look at the same evidence and publish their own papers, especially when it's kind of embargoed like this one. It was such a
Okay.
sensitive finding, they wanted to take their time and to bring it out into the public with this one team, that other teams had access to the same evidence. And some of them didn't agree. But again, that's how science works, right? You just don't have the right answer right away. It takes sometimes decades, which is why we're still talking about this 30 years later almost.
Oh yes, yes, I
Yes,
agree. So the worm-like feature is grabbing your attention. Really, it's really
exactly.
shocking when you see this. This is a bacteria. This is a microbe. So, which is now the non-biological explanation for this like worm feature? Why they say?
Well, it
What
could
other
have been.
what geological explanations are you right now?
I'm not a geologist, but there might be some process like water or some kind of liquid that was going through it,
Uh-huh.
possibly. But I would need to ask a geologist those questions because my doctorate is in the humanities part of science, not in the geological part of science.
Okay. And
Yeah.
you said, I read an excerpt from your book. You said that this became an object lesson in how not to reveal that life has been found on another world.
That's right, yes. So the lesson learned is don't get excited from one sample, okay? Make sure that you have two or three or four. A single point of evidence is hardly evidence, right? You need to have more than one piece of evidence to make a conclusion. And I think, again, the way that it was presented maybe was not presented as a question, but as sort of this is the truth. And that bothered some people, and it also confused a lot of people, including, as I said, people who were sort of helping out with the announcement, like NASA, who does have some scientists, but some of the policymakers, like the president.
Okay.
Yeah.
And geologist says about the crystals, so perfect, that shape is one of the worst things you can use in geology to define things.
That's right. They want to
That's
look at the mineralogy of the rock. They want to look at the environment where it was formed. They want to look at they also want to look at the organic materials and in what direction the molecules are made, right? If they're left-handed or if they're right-handed,
okay.
chirality is what they call it exactly. These are all aspects that are looked at commonly for life on Earth. Luckily, we can do it soon on Mars because the Rosalind Franklin rover from Europe is going to launch in 2022, land on the red planet, and one of its goals is to actually look at the chirality of these molecules, the organic molecules, to see if they go left or if they go right, and sort of see if they're similar to Earth or not.
Okay. When will we be pretty sure to find life in Mars? There are 3 incoming missions. Perseverance is one of them.
That's right.
Carry experiment to determine the presence of life. What if we find something like Vikings found? You remember? This will be conclusive, or only when we return samples to our laboratories in Earth, where scientists have the chance to reproduce results, compare it, publish. You know what I mean? We need experiment to be specific.
We do. So what I think we need is we don't have enough equipment on Mars. It's very difficult to get everything out there to take a look. I think the real answer will come when we bring the samples back from Mars to Earth, which should happen in about a decade, I would think, because Perseverance is going to go around the surface. It will find promising samples, and it will put those samples into what's called a cache. So it will put it aside in a little protective box or container, whatever you want to call it. Eventually, another mission will come around, pick up the samples, and send them back up to Mars orbit, where a spacecraft will take them all the way back to Earth, or all the way to Earth. And then we'll have laboratories that are, of course, very, very carefully opening these samples so nobody gets hurt. I'm very careful. I'm saying this during a pandemic, right? So I want to be careful not to alarm people. NASA, I should mention, has a whole planetary protection office devoted to making sure that we're not getting microbes on Mars and that Mars microbes won't be coming home. So they'll be doing all this work very, very carefully to make sure there are no problems when the spacecraft and its precious, precious sample get here.
Yes.
Then, once we have the big laboratories with their advanced instruments looking at the samples, I think we'll have some better answers.
It's so difficult to make or design specific experiments to prove extraterrestrial life, ruling out other non-biological explanations. It's really difficult to design a specific experiment.
I agree. It's very difficult to design a specific experiment. So I think we need an international team, and we need people that are used to looking for microbes during the very early stages of Earth, maybe 3.5 billion years ago, 3 billion years ago, 2.5 billion years ago, right at the edge of of our planet's history.
So for you, this is not final. The last word has not been said, and the debate continues.
The debate continues, exactly. So what we're hoping is enough people will buy our book, that Mars exploration will continue, and then in maybe 5 or 10 years, we can write another chapter for this book talking about what happens next. So the next edition of the book would have more information on the sample return mission and what it found. And maybe then it won't be a detective story anymore. It will be a great find of scientific history.
The book is on sale now in Amazon.
It is on. That's right. It's on Amazon. It's on Skyhorse, which is our publisher. Local booksellers are starting to get copies as well. So if you have a preferred bookseller in Argentina or whatever country you're watching this in, just try and support them, because obviously all businesses need a little extra help right now.
But the book is in English only.
The book is in English only, exactly. But if enough people buy it in South America and in other Spanish-speaking countries, or even in Portuguese-speaking countries as well, then we can get translated to those languages: Spanish, Portuguese. Spanish is very common in the United States, so I think that would be a natural second language to translate it into.
I offer myself to translate the book to Spanish.
Excellent. All right. I will let our publisher know. Maybe you can help us out.
So finally, Elizabeth, are you optimistic in the short term about finding life elsewhere? I'm
very optimistic. So you talked about Carl Sagan. He was one of my influences growing up, and the movie Contact.
Me too.
Exactly. So there you go. So the movie Contact, which is based on his book, there's a part in there where they're talking about if there's no life in the universe, it seems like an awful waste of space, right? You know, that there isn't anything else out there but us. And that's how I feel. I feel that there are enough worlds out there with habitable environments. And we're not only talking Mars, we're talking moons in our solar system that have a lot of ice on them and a lot of water, for example. So I'm not even finished looking for life in our solar system, let alone in the universe. So again, we have other missions that are going out to Europa and to other moons at Jupiter. And we already had a mission out at Saturn looking at the moons out there. So I feel very optimistic we will find life somewhere, somehow, and hopefully soon.
And the exoplanets also.
And the exoplanets also, exactly. Once we get big enough telescopes like James Webb or the European Extremely Large Telescope, or we could do some more observations with the great telescopes in Chile, of course, to see what's going on out there, because, they have some amazing work that is being done in that country to really analyze exoplanets and all of their characteristics. So keep on going, keep helping us out. Find some more good stories for me to write about, right?
It seemed that, yes, it seemed even Pluto have harbored life now because it's water, it's potentially, yes, it's water below the ice crust.
Exactly. So when we flew by, I say we, the New Horizons spacecraft by NASA flew by in 2015, it was surprising because it found mountains, it found perhaps an ancient lake, it found organic materials on the surface. So it's possible that something got life going on there, but we need another mission and we need more money. So that's a problem. I want to drop a spacecraft at every moon and every planet and every little world in this solar system. And where's the money going to be for all that, right? So I keep my fingers crossed we can go back in my lifetime anyway.
Which is your next project?
My next project?
Yes.
I have a book coming out about Canada's space program. I'm from Ottawa, Canada, so that will be coming out in October. And then I have 2 more books coming out about space in about 2021 and 2022, although we're still in the early stages of writing those books, so I'm quite excited.
You know, I visited Canada, Montreal, yes, several years ago at the meeting of IPS. IPS is the International Planetarium Society, because I am a member of this organization. Yes, but only a few days.
Only a few days. Montreal's only 2 hours from where I live, and I love that city. I was wanting to visit this summer, but of course there are travel restrictions, so I'm trying to be careful even in my own country. But Montreal is a wonderful multicultural city. It also is a big center of space exploration over there. They even have an Institute of Space Law at McGill University, so they not only do the theoretical side, but the political side and the lawyer side. So it's a great city to do space exploration, but I wish I could come down and see your country because our mutual friend Pablo de Leon has told me a lot about the program
it's
in
a
your
friend
country.
of us.
Exactly.
It's a friend of us, yes.
Yes, exactly. So hopefully I can get down there one day.
How is the COVID situation in your city right now?
We have been very lucky. So we watched what was happening in Italy and in China, and we made the decision very, very early when we only had 10 known cases to shut everything down. That was back in March. So we were in very restricted movements for about 6 weeks or 2 months. Now we're very slowly opening up, but we're wearing masks all the time when we're inside. And we don't have everything open yet. We have perhaps a few community buildings for limited services, and we have stores open, but you can't really sit in a restaurant or a bar for a long period of time, for example. You have to stay on their patios. And of course, we're doing social distancing, washing hands. So right now in Ottawa, we're doing quite well, and we're working very hard to keep it that way. How about you? How's your city?
Sadly, we are at the peak of the curve, you know. Yes, a lot of cases right now, yes.
Oh, no.
Yes, maybe because it's winter, maybe because the progression of the disease, of the infectious, you know, it's like logarithmic, you know, exponential.
Yeah. And the thing is, you can't let down your guard. So even though we're doing relatively well now, we know that if we make 1 or 2 big mistakes, we're going to be in a very, very big trouble. So we really watch everything that's happening, and we're trying to communicate a lot about how to make changes as needed. And it really comes down to responsibility. Every single one of us has to think about what actions we can take to help others. And so I, for example, am not really going very many places right now. I only really see a few people in person. The rest of it is, well, just what I'm doing with you on the videos. So I hope that they find a vaccine soon and that we're all able to normal, you know. Yeah.
Really, yes, really, for all the world. Elizabeth, thank you very much for your time. Thank you to join us, and good luck with your book and with your projects. And surely we'll talk again in the future.
Sure, thank you. And I also want to just mention that my co-author is Nicholas Booth. He's in the United Kingdom, and his expertise on these early missions, Viking, and also the meteorite that we were discussing today has just been great. You know, he was actually working as a space journalist during that time and really helped out with those chapters. So thank you again for having me, and by proxy him, on the podcast.
Good luck. Thank you. Thank you again.
En el marco de su plan energético a 10 años, ENERSA desarrolla obras de infraestructura en toda la provincia para acompañar el desarrollo productivo, permitir la radicación de nuevas inversiones y garantizar el bienestar de las familias en sus hogares. Más de 1.100 millones de pesos destinados a obras eléctricas para beneficio de todos los entrerrianos. Plan energético a 10 años. ENERSA, Gobierno de Entre Ríos.
Muy bien, era entonces Elizabeth Howell, que muy gentilmente se prestó a esta nota. Ella es periodista del sitio space.com. Este es un sitio de los más importantes que hay en el mundo sobre temas espaciales, que yo consulto bastante a menudo aquí para nuestro programa. Bueno, muchas gracias por seguir Ecos de un Mundo Estrellado. Los espero en el próximo programa. Muchas gracias.
Out to the capsule, now in recovery.
That splashdown came right on time.